How's it going, guys? Today I want to review another LeetCode question. Today we're going to be reviewing a question called shortest way to form string, and this is a question that's being asked a lot by Google right now. I don't really care if you cry. Alright guys, today the problem that we're going to be going over is from Google, and again, if you guys are new to the channel, I definitely encourage you guys to subscribe below and to drop a like on this video. I upload tons and tons of interview questions that are asked at big end companies that try and help you guys pass all of your interviews. The question that we're going over again today is from Google, and it's called shortest way to form string. And today our problem description says, from any string we can form a subsequence of that string by deleting some number of characters, and it tells us possibly no deletions. Given two strings, source and target, return the minimum number of subsequences of source such that their concatenation equals target. If the task is impossible, return -1. So it kind of sounds like a bunch of mumbo jumbo. All it's saying is we're given two strings, source and target, and we want to know how many different subsequences, or the minimum number of subsequences it takes from source to form the target string. And if that doesn't make sense, we'll walk through an example now. So example 1 says if our source is ABC, and our target is ABCBC, we would output 2. And the reason for that is the target ABCB can be formed by ABC and BC, which are subsequences of the source ABC. So if that explanation doesn't make sense, all it's saying is that we require 2 subsequences as a minimum to form this substring, right? Or to form this target from subsequences of our source. And again, those substrings are going to be first ABC and then BC. Great, so it took 2 subsequences, and that's the minimum number that we need, so we're going to output 2. Now in example 2, if we're given ABC as the source and ACDBC as our target, we'd have to output -1. And the reason for that is the target string cannot be constructed from the subsequences of source string due to the character D in target string. And all that's saying is it's impossible to form this target string right here, right, from this source ABC because source doesn't have a D. Right? And we need a D because target has a D. So now for example 3, if we're given the source string x, y, z and the target x, z, y, x, z, we would output 3. And the reason for that, it tells us, is a target string can be constructed as follows: x, z, y, and x, z. So again, if that doesn't make sense, it's saying the first subsequence of characters that we're going to take from our source to try and make our target is x, z, right? So x, z is the first part that we need to find, so we found that. Then we try and find the next part, which would be y, so we find a y. And then finally, we're going to find another subsequence that is xz, and that will give us 3 subsequences, and that's the minimum number of subsequences we need to form our target. Now for our constraints, it tells us that both the source and target strings consist of only lowercase English letters from A to Z, and the lengths of source and target string are between 1 and 1,000. Okay, so now how do we actually solve this problem, and how do we make sure that we do it in a minimum number of subsequences? So the first thing we need to realize is that every single time we try and form a subsequence to take, right, to try and form that target string, we need to make sure that we find the first letter that we're looking for. So in example 1 here, A is the first character that we need to make sure that we find, right? And so we find it actually coincidentally at the first index, so that's great. The next character then that we try and find is B, which we can also find in the second character, and same thing with the third character, right? ABC is the first 3 characters that we find, and we take that as our first substring. But it tells us, and it's important to realize, that the first thing we need to do is make sure that we always can find that first character that we're looking for in target in the source. So the important thing to solve this question is to realize that you always have to be able to find at least 1 character. Right? If you can't find 1 character to try and form a subsequence such that you'll get closer to forming your target, you have to return -1, right? Because if you've never taken a single character, if you're never able to find that first character that you need or the next character that you need in target, you can't actually solve the problem. So that's when you would return -1. So that tells us when we return -1. The next thing that we need to realize that if we can find a character, right? So if we're looking for an A and we can find an A, we need to try and greedily take the next character, right? Every single time that we find that character, we need to continue looking through our source to find the next character that we need to get closer to our target. So that's telling us that every single time we haven't reached our target yet, we want to find the longest subsequence such that we'll get closer to forming our target. Okay, so what we're going to try and do here is we're basically going to try and continue finding subsequences inside of source that will get us closer to our target while we've not reached the target that we need. So the first thing we want to do here is just initialize a return value, right? And our return value is going to be our minimum number of subsequences we need to form our target. So I'm going to call this num subsequences. And this is going to start at 0 because initially we don't actually have any subsequences, right? We've not tried or taken any subsequences to try and form our target. And the next thing I'm going to do is just create a string. And I'm going to call this remaining, okay? And this is going to be formed from target. So initially, all the remaining characters that we're looking for will be equal to our target. And as we find subsequences, we're going to modify our remaining string so we know what we're looking for next, right? We're never going to look for the same character or the same index that we need twice. So I'm going to say string remaining equals our target to begin with. So now we said that we need to try and take subsequences while we haven't found all of our target, right? And so in this case, it's really going to be our remaining. So what that's going to translate to is while our remaining length is greater than 0, that means that we want to try and find a subsequence to get us closer to our target, right? So once we're inside this loop, we know that we need to try and find a subsequence, so I'm going to start building that subsequence. So I'm going to say string builder subsequence equals new string builder. So next, once we know that we're going to try and form a subsequence, we need to make sure that we have pointers to actually point to the characters, 1, that we're on inside of source, and 2, that we're looking for inside of remaining, right? So I'm going to have 2 pointers, I and j, and these will both start at 0 because remaining we're always going to be modifying such that the first character is the character we're looking for, and then I, or whichever pointer we really want to use, the other pointer is just going to be pointing at the first index of source so that we can try and find that character that we need. So now I want to make sure I don't go out of bounds, right? I want to try scan these strings while I don't go out of bounds of either of them. So I'll say while I is less than source.length and j is less than remaining.length. What do we want to do? Well, we want to know if the 2 characters are equal to each other, right? Because if the 2 characters that were on I and j, if they're equal to each other, then we found a character we need, and we need to append that to our subsequence so that we can modify our remaining string saying that we've already found that character, right? So if source.char at I, and I'm going to say plus plus just so I don't do it later, if that's equal to remaining.char at j, which I don't want to increment unless I've found that character, right? So I'm not going to increment it yet because I need to add it still. So if we found 2 characters that are equal to each other, right? So the character we need to find in target or in remaining, if that's somewhere inside of our source, then we want to append that to our subsequence. So I'll say subsequence dot append remaining dot char at j, and I'll say plus plus because now we've found that character, right? So if I have this much left in source, I want to make sure I'm not looking for that character anymore, but the next one. So we're going to move j to the next character, and if we have this much left inside the source, right, we just found the character here, we want to make sure we traverse the rest of source trying to find the next character and the next character, so on and so forth. So once this loop terminates, guys, hopefully, fingers crossed, we will have found a subsequence that will get us closer to what we want, which is building that target string. But we need to have our check, right? If our subsequence actually didn't pick up any characters there, then it's not possible to actually form the target string from source, right? So that's going to be the case where like we need this D here in example 2, but we can't actually find it inside of source. So we'll have a quick check. So if subsequence dot length, if that's 0, then we have to return -1, right? Because it's not actually possible to form the target string from subsequences of the source string. But otherwise, if we don't trip that conditional, then we know that we definitely have a subsequence. So we need to first increment the number of subsequences we've taken. So we could say num subsequences plus plus. And then finally, we need to make sure that we actually modify our remaining string, right? So that we don't actually go and just stick in an infinite loop inside of line 5. So I'll say remaining is now going to be equal to remaining.substring. And what's it going to be a substring of, right? Or like how far do we move it? Well, we want to move it however many characters we just found, right? So if this is remaining, we want to move it forward however many characters are in our subsequence. So I'll say subsequence dot length here. Great, and so now once all this finishes, right, if we've never returned -1, hopefully all we'll have to do here is actually return, I don't know why I keep going outside the function, we'll actually just need to return the number of subsequences that it took us to form the target string. So now before we submit this, let's just quickly talk about our runtime and our space complexity. So now to talk about our time complexity, right? The worst case is really going to be for every single character inside of our remaining, we need to find it inside a source. And so in the worst case, we could basically do a linear scan of our source for every single character in our target, which would give us n times n runtime. So that's going to be n times m, where n is the number of characters in source, and we could say m is the number of characters in our target. Then in terms of our space complexity, well, space complexity is going to be O of m, right? Because we're building our target string. So in like the worst case, we're going to be building up a new string that contains our target string and then returning it. So I would say that our runtime is O of n times m, and our space complexity is O of m. So now let's run this code. Let's make sure that it works. Awesome, and it does. So guys, that's how to solve shortest way to form a string in Java. Again, this is a question super asked by Google right now. If you guys found this video helpful and enjoyed it, be sure to leave a like and subscribe to the channel below, and I'll see you guys next time.
I don't really care if you cry. You already should've never lied. Should've saw the way she looked me in my eyes.